And continuing on, graphing y equals -1/2 tangent of 2/3 x. Again, we're going to graph the tangent and the cotangent functions, and this time we have a different period on there that we're going to stretch our graph out. But we're going to do the exact same thing we were doing before. Since this is the tangent graph, my normal values for tangent, -pi/2, -pi/4, 0 in the middle, pi/4, and pi/2. With my tangent graph and my cotangent graph, I'm going to start and end with my asymptotes. 0 is going to be in the middle. For my tangent graph, I'm going to start in the negative, end in the positive. Unless we start with a negative up there. We'll get to that. So, again, we take the part in the parentheses, the 2/3 x, set them each to our x values here, -pi/2, -pi/4, 0, pi/4, and pi/2. And then we have to solve. So we would divide by 2/3, which is multiplying by 3/2. So I'm going to multiply each of these by 3/2. So this is going to give me -3pi/4. This is going to give me -3pi/8. This is going to give me 0. This is 3pi/8. And this is 3pi/4. So, between 0 and pi, 1, 2, 3, 4, 5, 6, 7, 8. Each of those are in pi/8. And so, first is my asymptote, last is my asymptote, 0 in the middle. Here I'm going to take -1 times the value in front of the tangent. Since I have a negative times a negative, it changed to a positive. +1 times the value in front of my tangent, so I get -1/2. So at -3pi/4, these were over 8, so I'd have to go -6. 1, 2, 3, 4, 5, 6. Here would be -3pi/4. And at +3pi/4, so 1, 2, 3, 4, 5, 6. 6/8 is the same thing as 3/4, right? -3/8. 1, 2, 3. I'm at +1/2. That one you have to use the plot point tool on. 0, 0. And then +3/8. 1, 2, 3. I'm at -1/2. So you'll notice here that this is in the middle of this is in the middle. They each just kind of split each other into parts. And then when I hit my graph button, it looks like the cotangent function because it's coming from the top and going to the bottom, but it's actually the tangent function. It just got flipped because of the negative in front of that tangent there. So on number 11, we are going to graph the tangent function again. Tangent function starts at -pi/2, -pi/4, 0, pi/4, and pi/2. We have an asymptote at the beginning and an asymptote at the end. 0 in the middle, starts negative, ends positive. So we have 2x, all right? Normally that would be in parentheses, but we don't need it on this one. 2x to equal our -pi/2, -pi/4, 0, pi/4, and pi/2. So we want to solve this one for x. If I'm going to solve it for x, I'm dividing by 2. Dividing by 2 is multiplying by 1/2. So I'm going to multiply everything by 1/2. The reciprocal of 2 is 1/2. So I get -pi/4, I get -pi/8, I get 0, pi/8, and pi/4. So we are doing the tangent. We have an asymptote at the beginning and an asymptote at the end, and 0 in the middle. We're going to do -1 times our amplitude, so -4 to start, then 1 times our amplitude, so +4 to end. So asymptotes at negative pi over 4, positive pi over 4. They had those marked good for us. 0, 0 in the middle. At negative pi over 8, I'm down at negative 4. At positive pi over 8, I'm up at positive 4. And so my tangent graph this time looks something sort of like that. And then we're going to do a cotangent graph. So on our cotangent graph, our cotangent starts at 0 and ends at pi. 0 to pi would be my normal graph. Pi over 2 is in the middle, so I would have pi over 4 and 3 pi over 4 for my other values. Again, I have an asymptote at the beginning and an asymptote at the end. 0 in the middle. The cotangent starts in the positive, ends in the negative on my normal cotangent curve. So, in my parentheses, I have 2/5 x to equal each of those values. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. I have to solve that for x, so I would divide by 2/5, which is multiplying by 5 over 2. So 0 times 5 over 2 is still 0. Then I'm going to get 5 pi over 8. Then I'm going to get 5 pi over 4. Then I'm going to get 15 pi over 8. And then I'm going to get 5 pi over 2. So asymptote at the beginning, asymptote at the end, 0 in the middle. 1 times 1/2 is 1/2. Negative 1 times 1/2 is negative 1/2. Almost can read the negative. I'm going to put it out there. So asymptote at 0. Asymptote at 5/2, which they happen to have marked, so I don't have to figure that one out. 5/4. 1, 2, 3, 4. I'm in eighths, so I'd have to go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be halfway between. It looks like it is. Should be right at 0. 5/8. 1, 2, 3, 4, 5, which should be halfway in between. I'm up to 1/2. And then I'm at 15/8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm down to negative 1/2. And my cotangent curve is going to look something sort of like that.